This part of the question asks us to sketch the original function f of x and the Fourier transform f of k as defined in the previous question for two different values of the parameter alpha, one large and the other small. And we need to indicate carefully which sketches correspond to which value of alpha. Now if we go back to the previous question, the resultant was a sinc function for the Fourier transform. And as we saw in the lectures, we can say how broad that function is. The functional part is the sine k alpha term, and this is equal to 0 when k alpha is equal to plus or minus pi. They're the first two zeros. And so we can see this, the first two zeros occurs when k is equal to plus or minus pi over alpha. So as we found with all other Fourier transforms, the width of the Fourier transform is inversely proportional to the width of the original function. The original function has a width of 2 alpha, whereas we can see in this case the width between the two solutions here would be 2 pi over alpha. So when we draw the function of the Fourier transform, we have to capture this inverse relationship, and that's essentially what you need to do to get the marks for this question. So quickly we can sketch. Let's start off by sketching a value of f of x. Let's choose a small value of alpha. So this is f of x. That would be minus alpha, that would be plus alpha. This is x. And then over here we'll sketch the corresponding Fourier transform. So this is now f of k. Now we've chosen a small value of alpha, so this means that the Fourier transform is going to be broad. Remember, a sinc function, it's an oscillating sine function, but it gets smaller the further you go away from the origin. So that would be the original function and its Fourier transform, and then we just repeat this for example, a much broader original function. So now minus alpha to plus alpha, this is f of x, this is x, and now what we need to draw is a Fourier transform having a much smaller width because now the original function is much broader. So now we would draw our Fourier transform, for example, to look something like this. The quality of the sketches doesn't really matter. The main thing is to show this inverse relationship of the widths. So we can see here we have a narrow, so this would be a small alpha. We have a small alpha, so we have a broad Fourier transform, and at the bottom we have a large value of alpha, so we have a narrower Fourier transform.